Welcome to another HDF webinar. My name is Gerd Heber. I'm the Executive Director of the HDF Group, and today it is my privilege to introduce James Mudd. And it's sort of, as we have found so many times, there is fantastic work going on in the HDF community that we are not aware of, so we are ignorant to a degree as well. And what I find particularly interesting is it has to do with Java. There are certain areas in the HDF ecosystem where we as HDF Group, for a variety of reasons that we can talk about another time, have not really done a very good job. And Java is one of those areas, and there are many others. Don't get me started on that. But then it is the more fascinating to see that someone out there in the community felt that need and had the right skills, the extremely competent and sort of the drive to just say, I'm going to do this. And so that's quite remarkable. And I think, yeah, we will hear about this and much more from James here today. So again, I'm really excited about, because I think Java, okay, these days, perhaps Python and some other languages sort of get all the buzz, and yeah, and many other languages, for whatever reason, we don't speak much about. But Java, certainly, I mean, if you look at Java 22 is going to release, either it released earlier, a few days earlier, or will be released next week. So there's definitely a lot going on. Just looking at the Java ecosystem, how other projects have embraced Java and had great success with it. So maybe we are at the cusp of, with James's work, of sort of a renaissance for HDF, for Java in the HDF ecosystem. And I look forward to James's presentation.
Well, thank you very much. And hello, everyone. Hopefully it lives up to that intro. Let's find out. So yeah, I'm just going to do a few slides. Hopefully you guys can see my screen share. Right, yeah, just first quickly, I thought I'd give a background of what I did and what I do now. So I did PhD at University of Warwick in the UK. It was on photoelectron spectroscopy of cadmium oxide. And with that work, I mostly did experiments at synchrotrons in various places around the world, UK, Europe, US a little bit. So that was kind of my first introduction to HDF5, because a lot of data sets I had at that point were stored in HDF5, and loading and analyzing them, I guess, was my core part of my PhD. So that was my first exposure to it. The light source, which is the UK synchrotron, and there I worked as a scientist for a little bit, and also then transitioned into a role as a software engineer. Yeah, at that time, I thought science was hard. I had like a wife and wanted to get a house and stuff, and I thought, yeah, let's get a better job that's a bit more, bit more stable. So I got a software engineering job, and I was there for about 5 years, and I did lots of work on the data acquisition software at Diamond, and then again, right, that's where I was like heavily writing HDF5, reading HDF5, and exposed to a lot of HDF5. And then I left Diamond and went to Ox Mountain, which is just I guess, a regular software company. They do data analysis of maintenance data to help companies optimize their maintenance strategies. And that was, again, it's a Java SaaS application. So I went from writing Java and Python in a kind of science background area to writing more production Java, writing what I would say is the 95% of Java out there, Spring applications, server side, and serving web services. I did that for another 4 years, and then I moved to my current company, which is Osprey Charging Network in the UK. So it's the third largest EV charging network. And the role is very similar to my previous role. It's still Java services, on our back end, and we have a few Kotlin services now as well, which I'll touch on a bit later. And we also have Android iOS apps. It's kind of like a normal software company, I guess. It's a normal trading company with lots of software that controls everything there. So that's about me. And what about jHDF? So the project itself, I guess most people here probably know, it's a pure Java implementation of HDF5, a library to let you read and maybe soon write HDF5 files in Java with no native code dependencies. So it started in 2018, basically as a small side project. I just had a few hours here and there outside of work, and started playing about with Java and seeing if I could read HDF5 files, which I had plenty of to look at that point when I was working at Diamond. And eventually got things working a little bit. I had some first release on Maven Central, which is like the central Java repository. That's one of the key, I think, things that's helped the uptake of jHDF in projects, is that it's very easy to implement in Java applications. And then as we see it carried on over the next few years, adding more and more features, covering more and more of the specification, so you can read more and more files that are out there. Then March 2020, we had the start of the COVID lockdown in the UK, and also pretty much everywhere around the world at some time near there. And I had my first child as well. So stuff changed a lot in my life, and my free time kind of disappeared mostly. But anyway, still carried on doing bits and bobs on jHDF until we get to where we are now. In the last few years, maybe not as much progress, I'd say, until really recently, when I managed to find a bit more time, I guess, in my evenings, and prioritized it more, and did a little bit of work towards adding writing support. So we'll see about that again a bit later in the talk. Just want to say, by the way, if anyone has questions or wants to ask, then feel free to jump in, and we can try and answer those as we go. Okay, so what do we have at the moment? I think in jHDF at the moment, I have what I would consider anyway a large amount of real HDF5 files out there can be read by jHDF, all the data types except time, which I think is minimally used. Most of the standard filters are done. Attribute support is done. This is reading, by the way, all reading. Compound array types you can read. N-dimensional data sets is okay. Checksum support is mostly there, but it's not checked in every single place where it could be. You can read files from disk, from memory, or from Java virtual file systems. So a lot of Java apps have wrappers around things that appear as virtual file systems, like, I don't know, a zip file or an S3 bucket or some other web object store. Lots of things have like a driver that lets you appear like a file system, and user blocks. So if you have a bit of header on the file, which you can write arbitrary content to, you can read that as well, and obviously read the rest of the HDF5 file underneath. So over time, guess picked up some decent users of this project. So a couple of them are shown here. The graph shown is the downloads from Maven Central. So it's around 2,500 a month. Had a huge peak before this graph where it went up to a ridiculous amount, but I think this graph's kind of meaningless because it really depends on how many people have your project in their CI builds, and therefore how many CI builds they're doing. So that's how many times you'll probably get your project pulled. But yeah, there's always people following it, so definitely people are using it. Right. So that kind of leads on to why would people use it. I think the core reason is, people Google HDF5 Java, and my library's one of the higher results in Google, I guess. And then when they look at the other options, I think they find that this is the simplest to get started. So basically, you just need to add a dependency through Maven, Gradle, whatever your Java build system is. It will pull the code from Maven Central automatically, and then it will just give you the classes you need to read files. So I'll show you how that works in a demo, but basically simple. No requirement to load native code. This is, I think, a bit of a pain. A lot of Java developers are not really that familiar with JNI, and they don't really want to require loading native code. So that's a bit of a difficulty with other solutions, that you pretty much always end up down that road. hopefully nice API, in my opinion, but I'm happy to be criticized there. People might have better ideas. I think there's maybe a few areas we could do better. Automatic mapping of data into Java types. So that's all handled seamlessly. So when you read a file with jHDF, you'll get a int array in Java or a double array or a string array or whatever. And the array dimensions will be the dataset dimensions. So you've got everything like given to you basically in the type you wanted it to. No use of JNI, again, for accessing native libraries. This is how Java calls into native code and how native code can call back into Java. It's, I guess, probably not loved by most Java developers, or at least most Java deployments. Certainly, like my current company, we would not deploy JNI because it's too risky. Like you're basically throwing away all the memory safety and protection given to you by the JVM in order to call some code which is unsafe and untrusted. So if you want to do that, obviously that you can, and that's fine, but you need to be in a use case where having your app crash or do stuff that's not expected is handleable, because otherwise you are risking that. Loading's lazy, which is nice. So anything, even if you open a huge file, let's say a file that I can't even read in Java, but you only access one small data set from it, that's fine. I don't go loading any other stuff that you don't need to get to where you want it to. It helps with that. Also, if you have very deep files with lots of groups, then no problem. Just go to whatever level you want and get it. And also, concurrent access is pretty much all there fine in jHDF. You can read many files simultaneously, many data sets in one file simultaneously. All the objects in memory in Java are immutable. There's no real concurrent access issues going on there. So depending on your use case, that might be a nice feature. But on the downside, Java have int max value maximum size in an array dimension. So that's a fundamental limitation of the language, which is not going to be solved by jHDF. And therefore, if you have really huge data sets in a dimension, it won't work. Currently anyway, but slicing might be a good solution for that. No unsigned types in Java. So the language, jHDF handles that. So it will promote your types for you. So if you have unsigned int, then you'll have long in Java and so on. But obviously that's going to cost memory. Not quite 100%. There's a few, I guess I would say, less used features, mostly because I've never seen files with them in that are not implemented in jHDF. So not everything will absolutely definitely work. And slicing of chunk data sets is not done. So there is slicing support in the language, and I'll do a small demo including it, but only for contiguous data sets, not chunked, which would be really good. Okay, so let me skip back to that. So let me do, so hopefully you can still see my screen. So what I wanted to do first with the demo was literally just like write a small file. In this case, I used H5 and then load it with jHDF. So this is the file. So it has like a small int data set. It has with an attribute on it. It has a compound data set with some people, and it has some bigger 2D data set with filters and gzip and byte shuffle. So you run this, then you end up with a file called webinar demo.hdf5. So just to show you what it is, let me just take this path and see there. Try to remember that I'm not on a Mac. Okay, so yeah, there's an integer data set, not very exciting data in there. Numbers up to 9. Some people, again, not super exciting. A group, and then some 2D data, which is bigger, and the same 2D data, but with byte shuffle gzip filters. Okay, so then let's look at jHDF. So first, you need a dependency on the library. So here, I added dependency on. This is actually on version 7.0.7 alpha, because there's another demo later for that writing, but probably you just use this if you want to have the most stable release version, and everything is there apart from writing. But for this demo, I'm going to use that. So it's basically a very small Java class, simple method, one main function, prints out hello, and then it loads the HDF5 file on this line. So this is the API, I guess, the main API you'll probably use if you use jHDF. Create a new file with some path. Here again, I just have the absolute path. And then the first thing I did was I just dumped out all the children, which is a map of the nodes inside of the root group, and write them to the system out. So let's just run it and then we'll see that. Right, let's scroll back to the top. So hello jHDF from here, and then this is the bit here where we're writing out what there is. So there's an int data set, there's a people data set, and there's a group. These are the things in the root, which hopefully agrees with what jHDF view also says. So that looks promising. So it's ready-defined. So then you can use the get dataset by path method, which in all the code I've seen seems to be a very popular way of getting it rather than traversing through the things. But this just lets you write a long path into a deep wherever you want a dataset, and it gets the int dataset, and it prints out path, and then it prints out the data. So on the int dataset called get data, and then what we end up with is which is that, and then 0 to 9, which again is good because that's the same thing we saw over here. So that's all looks good so far. Now I thought I'd just do something a little bit more interesting. So Java, I don't know, the Java library that that's the HDF5 group target release is targeted at quite an old Java. I didn't actually look it up. I meant to. I think pre-Java 8, maybe Java 7, maybe Java 6. I'm not even sure. But yeah, it doesn't have even what are really quite old features now, like streams. So one nice feature on streams is you can do the summary stats, and that just gets you this count, how many elements, what's the total, what's the minimum value, what's max, what's the average. So something we'll see more of in a bit. And then a demo of reading attributes. So on the int dataset, sorry, change that. There is one attribute called webinar date, and it's a string attribute, and that is getting that here. So on the int dataset, I'm calling the get attributes. Again, it returns a map of name of attribute to the attribute, and then I'm unpacking it. So entry set gets you key values, and then key colon what is the value, and the get value here gets you back an attribute object, and on that attribute object there's all the methods that you could use on a dataset object. You know, get the data type, get the data, get the size, get all kinds of stuff. So then yeah, getting the data in this case I'm just writing it out. So here again, int attribute is webinar date, and the value of the thing is March 15th 2024. Try and speak properly. So again, looks like attribute reading is fine. Then a little bit more traversing. So go to a different child. In this case, I'm getting the sum group. And then from the sum group, get another child, which is the byte shuffle child. And then we get the byte shuffle data set. And this one is inside here. It's this thing. So again, looks like it works fine. It's 7 by 50. It's shuffled gzip, as I mentioned before. So I think I print out some general, so this is showing like reading other metadata about objects in HDF5 file. So for example, filters, yeah, it has a shuffle filter and a deflate filter, and then it has dimensions of 750, and then it has total size of 2,800. I don't know if it's shown here or not. I think it shows the compressed size. It shows the uncompressed size, the size of the bits. It shows the compression ratio calculated here, 2.28. I don't know if it's the same as this. Hopefully it is. Yep, 2.28. So it looks like, again, that we can read lots of metadata about different data sets. All those methods are there on attributes as well, and the relevant ones are on groups. So then let's get the data from there. And then obviously that did this chunk data set with filters. So it has to build the filter pipeline, then it's reading the data blocks, it's passing through the pipeline, and then it's converting them back to the relevant Java type. So, and then in this case, there you go. You end up with this object here, which is a double array, I think, of 7 by 50. So if we just, let's go and just inspect it a little bit more. Let's just run this thing in the debugger. I just want to see, just to give you an idea of the data objects. Yeah, so it's a 7 by 50 array. Values are there. So that's all good. And the data set object itself has lots of metadata objects in it. For example, it's a floating point, a Lendian, 64-bit in this case. Its data space is 750. Its storage is jumped somewhere. I can't see it, but there are messages about chunking. But yeah, anyway, you can see that it's got all the metadata there that it needs to redefine, also to provide all these other methods. So then another alternative for reading is flat. So instead of get data, there's also get data flat. Just squash it, just unrolls all the dimensions into one long data set. It seems like, again, looking at code that people have written with jHDF, that this is popular. Indeed, they like to pass it into other libraries which handle all the dimensions, or they don't care about the dimensions, so they just want to get it unrolled. So that's get data flat. I think if we print that, it will be the same. And I'm just going to run this all the way through to the end. And then slicing. So slicing is there, but as I mentioned, it's there for contiguous data sets, not for chunk data sets. So this 2D data is the same data set as this, but written without chunking and without filters. So in this case, you can call get data and pass in an offset and a size that you want to slice, and then you'll get a slice. So we're reading from 0, 1, and we're reading 2, 5. So hopefully that is printed somewhere. Sorry, I was in the debugger here, so it's a little bit messy, but data slice 2 by 5 from 0, 1 is starting from 50. And I think that is hopefully agreeing. We're reading here, and we're reading the next 5, and then by 2, so the next 5 there. So a little block inside of that data set. So slicing works in contiguous, but it's not implemented in chunks yet. It's something that I'd really like to add. And then finally, I did a bit more of a tricky data set, the compound data set, where it reads the data as a map. So the data set here is the people data set. The data type is compound data type. And then it looks at the keys. So the key set of the map is the columns titles in the compound data set. So let's just pop back to HDF view and have a look at it. First name, surname, gender, age, favorite number, vector. So yeah, it should be the same here. First name, surname, gender, vector. And then it gets a few of the values and just dumps them out. So for first name, it's those things, age is these guys, and vector is these guys. So that was my quick whistle-stop tour of using jHDF, I guess, and accessing a file with like basic example data sets in there. Before we move on, any questions or any suggestions, issues? Okay, cool. Then next, I guess, let's look at something new that's coming very soon, hopefully, to jHDF, which is writing support. So hopefully the API is roughly similar, but still work in progress. So this is on the 0.7.0 alpha, which is public, you can get it, but I'm not claiming it's perfect, and I'm not claiming it works in every case. But yeah, very similar API. So instead of HDF file read, you got write. and some path to where you want to write. And then you end up with a writable HDF5 file instead of HDF5 file. And then you can call methods like put group or put data set. So if you put the int group, then you'll get back the int group. And then here I made a int data set, which is it's just a 1D data set going from -5 to 5. And then I wrote that inside of the int group and put data set. So it looks, I think, very similar to H5Pi's API, but it's a bit more Java-y, but I think it's very similar, and hopefully it's quite understandable. And then another data set, which I just made a 2D array with some other random numbers, and then write that one in. And then I wrote another group called double group, and then some more double data just to show some other types. And I finished writing that. So I'm just going to run this one. It doesn't really do much. It doesn't print anything particularly exciting. But what you end up with is webinar writing. And let's copy this one, absolute path. Let's see if we just open it. Yeah. It's got the two groups that we wrote, int group, double group, and int data. I think we have the 1D data set -5 to 5. 2D data set with those random numbers. Hopefully it's the same numbers that I wrote here. Looks promising. And yeah, that's basically it for writing. It kind of works how you expect, apart from with very limited support at the moment. You can write like doubles, ints, bytes in n dimensions and groups, and that's about it. But yeah, hopefully more writing support can be added, and when I have more time to work on that. And then I thought I'd show. Sorry,
I do have a question.
Yep.
So are you able to open a file for appending?
Currently, no.
Okay, so that would be something I would be interested if other people have asked for that as well.
Yeah, that's quite challenging, I think. Depending on how much you really need to append versus how much you can live with reading what we have and then writing out a new file. If you can live with that, then it's probably okay. But if you really need to append, that's significantly more difficult. I think because my current writing approach doesn't do anything like what HDF5 library is doing with free space tracking and finding places to write in and leaving gaps in between like object headers so that you can add messages to headers easily. It's not doing that. It's basically traversing the tree as it's writing. So it's going through the structure and it's writing all the blocks basically contiguously with no free space left in there. So it means that to modify a file in place is significantly more difficult at the moment for jHDF. It would have to replace object headers basically and write them at the end and leave gaps, which is doable. But again, it's something that I'd like to do, but it's not like the next thing on my list because I think it's quite a big challenge. And yeah, that's my view on it. I guess I'd be interested in other comments, but yeah, it's not going to be here next week, next month, or yeah, probably for a while.
No worries.
No problem. But yeah, but like I say, it depends what size data you're really working with. Because if you can live with reading back the data and writing out the whole file again, I think that could be much more achievable.
Yeah, I've had to do that with other libraries too, and that's fine.
Yeah. Okay. Well, then in that case, maybe that would be possible a lot sooner, hopefully.
I see how I can do that myself too. So.
Yeah, no worries. Okay, that's nice to know that people are making good progress with that. Okay, good. Then I thought I'd show you something a bit different. So I thought I'd show Kotlin Python notebook. So I guess one thing that people were interested when I was asked about this talk was about Java ecosystem in general and where it is and how things are changing. I think there's a couple of slides I got at the end about that, but one thing I think is that although my library is, I guess, old and compatible at the moment, it supports down to Java 8 still, although I'm very soon probably going to drop Java 8. But there's a lot of features in newer Java that are coming. And then there's a whole nother world of other JVM languages like like Kotlin, which is, I think, becoming very popular. Obviously, Scala, Groovy, and others as well that are still there. But for example, Kotlin have quite a lot of data science stuff going on there. So they have one thing they're working on in JetBrains at the moment is this kind of Kotlin notebook thing. So it's very similar to IPython notebooks or Jupyter Notebook. So it's like that, but only it's using Kotlin. So Kotlin's another JVM language, so it has full interoperability with JVM libraries. So things become quite straightforward to read, and they have support for things like data frames, which are very much like pandas, and have support for plotting with various libraries, some of which are the exact same shared with Python. So I thought I'd just give a quick demo of this. So for some reason I don't understand, running the initial imports on a Kotlin notebook takes a surprisingly long time. But anyway, once that bit's done, hopefully the rest of the thing is quite fast. So that takes 5 seconds, but then loading the file 300 milliseconds, and then here it reshapes the loads the compound data set that we saw before into a data frame, and then it's very much like like I said, like Jupyter Notebook data frame or Pandas data frames. And then it has filters like you see on those as well, data science type things, filtering, finds only the people over 30, or finding people whose name starts with P, or finding the men, or plotting the data. So here I plotted, I don't know what I plotted, favorite number and age against name. So it kind of like, I think gives people an alternative to what people are, or not alternative. It's like very much inspired by, I think, by the Python ecosystem around data science, and it's very similar to that, only it's on the JVM. So for some use cases, I think that's quite compelling. If you have a lot of Java already in your company or in your backend, then this could be quite nice. So that was a quick demo of the small file, and then I thought I'd better show something that was a bit more interesting. So I got another data set. This is a public data set of weather from various cities around the world. And CV, you can download it from here, but it's a CSV file. So I use pandas to read it, and then printed out a thing, and then wrote it out to a HDF5 file with chunking, compression, and it's called weather.h5. It's this thing here. So I'm not going to run that now just because it takes like, I don't know, a minute or something. But let me show you it when it's built. So it's pandas style. So it has basically the weather in this folder, and then it has table, which is the whole object, which is what 5 million rows. So I realized after I'd done this example that I'd kind of made it hard for myself, because compound data sets is really a rubbish area for jHDF in terms of performance. But anyway, well, I did it. So it's the same thing. It loads some Kotlin libraries and HDF5, and then it reads this file, and then it calls get data here. So this is where we're actually going to read everything. And then it casts this thing to a map. Did that run? Okay. Cast it to a map, because that's how jHDF reads compound data sets. As I said, it's like a map of column name to the data. And then it does the same thing where it reshapes the data into a data frame. And then it does a little bit of like data sciencey stuff. So reading this took nearly 7 seconds. I think I read it in pandas. From HDF, it took about 5 seconds. So it's not much different. And as I said, this unfortunately is a bad case for jHDF. I shouldn't have really used this example, because if it was a double data set with deep array, it probably would have been faster than this. But anyway, such is life. Then it prints all the countries that were in the data set. And then it does some plotting, which again takes a while because it's quite a bit. But anyway, I filtered. Or does it work? I don't know. It's supposed to work. It finds 5 countries, and then it finds only those countries in the data, and then only values where the temperature is real. And then it just says, okay, let's only look between 1980 and 2000. And then it plots the country with close. apart from it doesn't, because I don't know why it didn't work. Let me run it again. Okay, because I didn't have the notebook trusted, apparently you can't display a graph. So yeah, so it's very similar in that respect to Python style notebooks, and obviously jHDF is a nice way if you want to use that. And another case, like I showed on my slide before, Kotlin DL, the Kotlin Deep Learning Library. It's one of the libraries that uses jHDF, and they use it to load machine learning models, which are trained in Python, but then they want to implement them Java, for example, I don't know, in an Android app or in a Java backend on a web server. Then that's another nice use case for jHDF, where the model isn't actually that big once you've got all the once you've finished the training, you just have all the coefficients to load. Okay, that was a little demo of that. I don't know if anyone has any questions. I'll publish this, all this code, by the way, after the webinar. I'll put it on GitHub and put a link to it in the forum or something so people can, and then the comments on YouTube. So if anyone interested in reproducing this themselves, they can do that. Okay, then let's go back to the slideshow. Yeah, one thing I wanted to talk about, I guess, is Java really changed in the last 5 years, I guess. I don't know when Java 8 was released, but since Java 8, since Java 9, really, they transitioned to this much more fast release schedule. And so now there's much more releases of Java, of which only a few of them are LTSs. And the LTSs, I guess, are the ones that people really target for running production applications. But there's obviously all the other releases as well in between, and they are quite interesting for new features and preview features and stuff coming to the library. So anyway, I just thought I'd pick up on 2 features, probably the most related to HDF5, virtual threads and foreign function memory API. So virtual threads probably isn't such a, I don't know if there's a huge use case in HDF5 for this, but for web servers, it's quite big, because what you'd like to write is some procedural code where you have a HTTP endpoint and someone calls it, then you usually need to do some kind of work, like talk to your database to get the user or find out what the thing they're requesting is, and then return it to them. So within the time you spend in your Java app, like 99% of the runtime of that call is spent waiting for your database to reply to your request. And that means that's blocking IO, which isn't good, because that means if you had one thread and that application, you just have one, you just be able to serve one request every 200 milliseconds or however fast your database is, basically very slow. So then people work around that, right? So you just say, okay, that's fine. Let's just have 50 threads or 100 threads or whatever, which is fine. But platform threads are really expensive and take a lot of memory and are slow to create and are slow to release and all these problems. So you end up with like a maximum of like 50, 100 platform threads. So then, yeah, you can serve a lot more people a lot more quickly, but still you're wasting a lot of time where you're mostly blocked waiting for IO from your database or your file system or whatever IO you're doing. So virtual threads, the idea is that they're not really platform threads anymore, but they're really lightweight threads virtually inside the JVM, which when you get to blocking IO, automatically unmount themselves from a platform thread and then release that platform thread to join and to be used by another virtual thread. So the idea is, instead of having to use something like a reactive library where you write callbacks, so the library itself, the framework handles pausing your application until the database comes back to you, or pausing until your file read is finished and then calling back into your code. You can avoid that and you can just write blocking code. But when you actually get to the blocking method, just freeze your platform thread, and then other stuff runs until that call finishes, and then it's queued back automatically to be reattached to a platform thread, and that virtual thread will carry on. So that's quite a nice feature, and already lots of people are playing with this in web server code. So you can really handle a lot of requests in a much more CPU efficient way. So you can handle a lot more threads with a lot of CPU. And yeah, basically platform virtual threads are almost free. You shouldn't worry about creating them. So 1 million virtual threads is doable. And the JVM is handling that for you. And then probably a lot more directly related to HDF5 is the foreign function memory API, which is preview still in 21, and I think it's final in 22. Someone on the call might already know that, but basically it's going to be an alternative to JNI, and eventually maybe a replacement for JNI. It gives you stuff that you unfortunately need if you want to call native code, like deterministic explicit memory management. So you can define some memory and then call into some native code, passing a pointer to it, and then you know you have to know when that native code will not touch that memory anymore, and you can free it explicitly. So that lets you avoid the problem of JNI, which is that off-heap memory cannot really be freed until the objects are garbage collected, and that is slow. So you end up with a lot of memory occupied for a long time after you don't actually need it anymore. And that can cause you to run out of memory easily with JNI. So it's a bit of a problem. We can have much larger buffers indexed by long. So I don't know what it is. It's a huge amount of memory instead of the 2 gigs, which is at the moment limited by signed int addressing. Better than JNI performance because they optimize some things, especially for callbacks. So if your native code calls back into Java, then that will be like 5 times faster than it used to be. So that's quite cool. And then this is quite a big one, I think, the jExtract tool, which is the idea is at the moment when you use JNI, you have to write a Java stub declaring some methods that you want to be natively implemented, and then run the Java compiler with a flag. I think it's -h maybe, that says generate me a C stub for this. And then you get that stub file, and then you have to write some glue code there yourself, which goes between that C stub and the real native code you wanted to call into. And then you have to run all that together. You have to load that code at runtime. So the idea of this jExtract tool is you instead have a tool which you pass a native library to, and it will automatically read the headers and read the method signatures, and it will auto-generate the Java bindings for that. So you don't need to write any C or native code. You can actually write anything for JNI. I think you can assembly if you want, but you don't need to with this jExtract tool. It will just give you the stubs that you need in Java, and you only need to write Java code to call it. So that I think will be nice, and it potentially gives a way for people to use this tool to implement like automated build pipelines where you can kind of generate a Java API semi-automatically from native code. And I think this is big for Java because in these areas like machine learning and big data, I think Java has fallen behind because there's not good bindings to stuff like CUDA and low level OpenCL and things like that, which you need that performance for these machine learning workloads. Otherwise, it's just not going to happen. It's going to be too slow. So this will be a bridge for that, I think, to allow Java to come into that area. And I think it's my final slide, which is about more Java VMs. So there's 2 that I wanted to say that might be interesting here to people. Graal VM, the main thing that's cool about it is it's a Java virtual machine runtime like normal. It has some nice JIT optimizations on top of hotspot, but that's probably not going to affect most applications that much. But the cool thing is native image generation. So one thing that the JVM is not good for either is like serverless computing workloads where, let's say, you have some event-based architecture in AWS or something, and you fire Lambda functions every time you receive some event. The problem with the JVM is that there's a lot of startup time, especially when you launch a framework like Spring or something, which has a lot of reflective class loading at the startup. So it might take like several seconds until after your JVM starts before it can serve requests. And that isn't good in these serverless workloads because you're paying per CPU millisecond or something. So you want your startup time to be really short, and so that also that your scaling is as good as possible so that you can scale up quickly and scale down quickly. But with this native image generation, that's what you get, apart from I skipped past all the useful stuff there. Sorry. Can I go back? Sorry. Yeah, so that's what you get there. So you'll get very fast startup time and less memory usage because you don't have to, you've built basically a native binary that doesn't have all of the other Java classes that you never use. And one of the really cool thing about GraalVM is it's a runtime for other languages as well. So they have this framework on top of it. I think it's called Truffle, but I might be wrong, which is a way of implementing other languages on top of the JVM, including JavaScript, Python, Ruby. These are ones they've already done, WebAssembly. And they have interoperability with Java as well. So, and between themselves. So if you wanted to use GraalVM just to run Python, you could do that. So it's kind of cool. And the good thing why you might want it is you get the JIT. So yeah, just-in-time optimizations in Java, I guess, are one of the main cool things, right? That you can write code that you don't need to worry about trying to think about the optimization when you're writing it, because when it runs, the JVM is doing a lot to help you to make that code performant. And you can get that in other languages if you use something like GraalVM. And then there's another cool project, I guess, called Tornado VM. I think it's more niche, but basically it's allowing people to run Java on GPU and FPGAs. So this is really like the machine learning people out there who want to use CUDA and OpenCL and stuff like that. Yeah, they have automatic generation and automatic bindings to GPU. So you can just add annotations to your Java code, run it on the special VM, and then it will be optimized to run on a GPU, for example. I actually have no experience in testing Tornado VM, so I can't really speak to its performance or how easy it is to use or anything, but it's certainly an interesting project and one thing that people are doing with Java. Okay, so that leads me to nearly the end, I guess, which is what's the future for jHDF, which, or at least in my view anyway. I think writing support is nearly there. As you saw a demo, like it works, but it just has a few rough edges that need to be cleaned up so that it can be released. Slicing of chunk data sets, I'd say, is the only big remaining feature that I don't have in reading. So if that's done, I would say the reading part of jHDF is finished. But time data set, the time data type, sorry, I think it's not really used and it's small, so I can do it, but it's not going to change the world. Then newer features, maybe we could do something like Swimmer or other HDF5 post 110 features. Again, I have no one asking for that in GitHub or talk to me ever about these things, but maybe some people are interested in that. This is something that I think would be cool. Some kind of HDF5 object mapper. So people who work in Java are probably really familiar with object mappers like Jackson or JSON, and they go from a JSON representation to a Java object representation of some data. And I think the same thing could be done with HDF5, right? Because it's perfect for that. It has hierarchical structure. It has all the types you need for, int, double, string, blah, 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 everything you need. So you could have an object mapper that takes Java objects, writes them to as a HDF5 file or reads them from an HDF5 file. So it would give Java developers, I think, a really easy, nice, persistent way of persisting objects to disk, especially objects that are like, array heavy or don't really go so nicely in JSON or where you want compression. So I think that could be a nice feature. API supporting slicing with streams. Yeah. So I think in terms of making jHDF cool or nicer to use, I think that's a big area. So if you slice, I don't know, let's say you have a 3D data set where it's just a stack of 2D images, right? It's a common use case. You might want to loop through all the images, right? So you want to take the first frame and do some analysis, then take frame 2 and then take frame 3. So I'd like a slicing API where you can say that. So let's say it's a 10 by 255 by 255. In the first dimension, and then star. So like give me the other two dimensions as the slice, and then return that as a stream. So in Java, you just get a stream, and you get in the first element of the stream is frame 1, and the second element is frame 2, and the third element is frame 3, and so on. And that would just make it really nice for people to use, I think, from Java who are familiar with that kind of workflow. And another thing about that, I think it'd be nice to have similar API support in Kotlin, especially for things like the data frames stuff that I showed. If there was a method on jHDF to read as a data frame, you could do a lot better optimization than what I showed in that notebook and the mapping. And I think that would be nice if people really want to use Kotlin data frames or Kotlin deep learning or any of these Kotlin data science libraries. I don't know if it's really that big, but if people want it, I think it will be nice. And then maybe you could do a HDF view like app in something like Kotlin multi-platform. So Kotlin multi-platform is a cool GUI framework for cross-platform development, Android, iOS, web, desktop in Kotlin, and you could use that to build a kind of HDF view like app across all those platforms, hopefully in a relatively modern way. That's the end. Thank you very much for listening and the demo, and hopefully you've got something useful out of all of that. And yeah, thanks for listening. Any questions?
Thank you. Fascinating presentation. There is a question here in the chat. Someone is asking, would the gatherers from Java 22 help with the stream slicing? And there is a URL here to somewhere in OpenJDK JABS 461.
It's a good question, and off the top of my head, I am not sure. I'd have to look at it. The problem at the moment for me is I don't know what to target in terms of compatibility with Java, right? So at the moment I have Java 8 as the lowest supported Java version, right? And to really, okay, after Java 11, I could do something like multi-release jar, but it's not that easy to add features for newer, like I don't want to say you need Java 22, for example, right? And that's what, if you want to use some new APIs around there, then you might need to restrict that, and that's not something I want to do really at the moment. But multi-release jars, yeah, is a good example there.
Mm-hmm. And there's another question here. Did you look at the HDF high-level Java API? Does jHDF share that interface? I hope not, but
I did look at it, but it does not share an interface.
Good choice.
I reimagined the interface how I thought would be nice. How I thought that would be nice to do it. So yeah, that's where it is basically. I didn't copy it, and I think it could be a possibility to extract an interface. I thought about doing this at one point from jHDF and say like, okay, I could have this interface and have multiple implementations of it, like the pure Java one, and then one that's also using the bindings or native library or FFM or something else underneath. And I think it still might be a possibility, but I don't know whether, whether that's whether that's something that will be useful.
Mm-hmm. Great, and we just got a vote here for Java 8. Some people are stuck on that.
And, well, it's nice. Thank you for saying that. I said my own work were quite good, right? My own company, we're running Java 17 in production at the moment, and our newest apps are in Java 21. So we're not that bad, but I completely get it why people are on Java 8 still. And it's not that straightforward to move, and it depends what your application is, how easy that is. So yeah, that's why I don't want to drop support for it. But just to let you know, it will be going. I think maybe my intention is to release the first support of writing with Java 8 still, and then that's it. I'm not going to do Java 8 anymore. Sorry. So just let you know it's coming. It's going rather. Yeah. And I think that's in line with everything, really. Like the newest Spring framework, for example, they only have Java 17, I think, up. So like stuff moves on, unfortunately, and eventually you have to kind of give up and say, yeah, I can't keep supporting the older versions.
Mm-hmm. I have many questions, but I have one question, which would be, okay, you mentioned JExtract, and then of course you had plans for maybe implementing some of the things that jHDF doesn't support currently. Would the following model, like a hybrid model, and I'm going to explain what I mean by that, even make sense, or would this be more like a monster? And what I mean is, okay, Could you have, from an architectural point of view, jHDF, and that's your main, that's sort of on a motorcycle with a sidecar, that's sort of the motorcycle. jHDF is driving the development, and we don't want dependencies on native code and all the rest of it. But then for the time being, we have sort of that sidecar that, let's say, we generate with jExtract. And for the time being, we really use it as an extender that just sort of tides us over until we perhaps support something in jHDF natively. But for the time being, we just fall back to the C library to just get the job done. But that way, sort of have an evolutionary path to do more for existing users who say, well, I wish I could do this, or I wish, yes, you can. Of course, we want to be transparent in the sense that there should be a mechanism that allows you to completely disable or sort of leave that sidecar behind. If you want only pure HDF and no native depend, that's good. But yeah, would such a hybrid even make sense? Or would you say, well, you would be creating a monster kind of that way?
My initial guess, my initial impression is I wouldn't be really keen to do it. But on the other hand, I did do it actually a little bit. So jHDF supports dynamic filter loading at the moment, like HDF5 library does. And the way it does it is with Java service, what is it called now? Service loader. Java service loader. So if you define a specific jar with a special manifest header that says I provide a service of HDF filter, whatever the type is, I can't remember, then it can load it. And there's some filters that I don't know if there's any Java implementations. So or at least, yeah, not that I know of. So that was something I did. I can't remember what filter I had. Blosk. That, right. So then you're saying, okay, here's another add-on. If you want this thing, you can have it, but you're taking native code dependencies to do that.
Yeah.
So yeah, it could be done like that. Whether you could do it inside like the core API, so like, for example, like for getting chunk dataset reading, slicing, sorry, chunk datasets. I think it would be really hard to implement that in a nice way, which you could switch it off easily. Yeah, but I haven't really thought about doing it. But yeah, I think it would be challenging, but interesting. Yeah.
Okay, and we have another question here in the chat. Somebody's asking about NASA CDF files. They map file contents into an NIO buffer so that the software can use the file itself as a backing store. It's kludgy, but it's an interesting use case. Is there a way to make the number available to Java without copying them to the Java heap? But yeah, so the person said they had to leave, and
yeah. So I'm assuming a little bit that they're using off heap buffer in JNIO here. So yes, it should work. I think in jHDF, I haven't really tried it, but there's a constructor for the HDF5 file which takes a it's not a use case that I have, and I don't test it, but it probably would work, is my guess.
Okay, and it's 12 o'clock. There's tremendous interest here, but we also have to be mindful of everybody's time. And I hope anyway that this is just the beginning of a great discussion to be continued. And thank you again, James, for, well, creating jHDF to begin with, but also giving this fantastic presentation here today. And yeah, let's very soon try to find ways. And of course, yeah, we will try to reach out, give people who would be interested in participating in this discussion to join in. And yeah, I hope this is just the beginning of interesting work going forward, and maybe with also greater participation from the community. I mean, I don't know if you had a chance to look at the participant list. I saw quite a few new names here. I don't know if you were familiar with some of them.
No, I think maybe some people are definitely participants occasionally on GitHub and raising issues and stuff there. So thanks to everyone who talks to me on GitHub and shows me stuff that's not working in my library. And I even like it when people sometimes say that stuff is working, which is always great. But usually it's working, but there's one thing. Yeah, I fully accept that's what it is. But yeah, thanks to everyone who participates there, and also people who contribute with pull requests there and fix stuff for me. That's always much appreciated. So yeah, thanks, and thanks for everyone who also came to listen. I hope it was at least a bit useful, and thanks a lot for inviting me.
Great, thank you, and have a great weekend, everybody. James is in the fortunate position that the weekend has begun, kind of.
Indeed, that's it. I'm finishing for the day.
Okay, thanks a lot, and take care, everybody. And
yeah, it was really interesting.
You.
Yes, thank you very much.
Bye.
Thank you. Bye.